What's up, math scholars? Mrs. Hart here, making sure my microphone is plugged in. That's a bad day when it's not. Okay. It's Monday, and it's kind of sort of not raining outside, so that's nice after yesterday. We are going to finish the unit circle, so dig that out of your folder, and we're going to fill in all the blanks that we still had left after Friday's lesson. Okay? Who's excited? Unit circle Friday, yeah! You're actually pretty awake today. That's pleasant. All right, so here's your unit circle. Last Friday, I showed you how a unit circle is actually really tiny. This is a picture of it over here on my whiteboard. Basically, it has a radius length of 1 unit, which makes the coordinates here at 0 degrees. Which coordinate? 1, 0. Up at 90, what was the coordinate? 0. Yeah, we're just kind of refreshing. What's the coordinate over here at 180? -1. Good, and what's our coordinate down here at 270? 0, -1? Okay. So what we're going to do now is kind of talk through what these other coordinates are going to be. They're all going to have radicals in them. Before we get to that, I want to refresh the quadrants. This is called quadrant 1, and everybody who lives in quadrant 1 is positive, right? Positive x value, positive y value to get in quadrant 1. Do you agree? I'm just going to write positive out there in space somewhere. What is this guy over here called? Quadrant 2. Are they positive people in quadrant 2? Nope. They are negative positive people. It's not letting me write that very effectively, but write it somewhere. Negative, positive. There we go. Down here in quadrant 3, what are they? Negative people, so they're kind of sad down there. And then quadrant 4, what are they? Positive, negative people, because they have positive x values and negative y values. I'm going to take you back a slide real quick and have you write down a couple decimal equivalents for me. I want you to write down that radical 3 over 2 is the same thing as 0.866. And that is so, like if you would type in, I don't know, in your calculator, cosine 30, and you'd see 0.866, you would recognize that number. That's for your recognition purposes. All right, the next fraction you're going to see a lot today is radical 2 over 2. That is equivalent to 0.707. So if you ever go to your calculator and type in sine of 45 degrees, you get 0.707. And that would be equivalent to radical 2 over 2. And then 0.5 is equivalent to what fraction, of course? 1/2, because that number comes up a lot. So our whole entire unit circle, every other blank, is comprised of these 3 values. And that's it. There's not an overwhelming number of values. So let's head back to our circle. Our first stop is 30 degrees. We're going to do this by color today. So if you want to do it by color with me, get out a couple different colors of pens or markers or something. We'll have 30 degrees be a blue dot. We'll have 45 degrees be a pink dot. And we'll have 60 degrees be a green dot. Because the unit circle is nothing more than a bunch of reflections. Hopefully you geometry people remember how to reflect things. Yeah, people digging around their book bags still, so pause a minute. All right, we are back, and it looks like everyone's got their markers out for ready. Let's start at 30 degrees. I'm going to use blue for my 30 degrees. What they are going to do, and you don't need to do this, but what they're going to do to figure out that coordinate is put a 30, 60, 90 degree triangle on here. I know some of you are real geometry scholars. If you have a 30, 60, 90 triangle, and it has a radius of 1, a hypotenuse of 1, you can use geometry methods to find out this leg and find out this leg. This will be how far to the right our dot is. This will be how far up our dot is. So my question for you is, what's going to be bigger, x or y?
Yes.
Definitely x. That helps me remember. If my 3 choices are only 0.866, 0.707, and 0.5, you're going to go with the biggest number available to you for this. So it's radical 3 over 2, or 0.866. And then 1/2 is going to be the smallest number available to you, which is 1/2, or 0.5. That's your first dot. Radical 3 over 2, 1/2. All right, do you remember anything about reflections? Reflecting. We're going to go around this circle and reflect that blue dot to 3 other places. If I'd reflect this dot over the x-axis, where would you land? Bam. Yeah. Down at 330. If I'd reflect it over the y-axis, where would you land? Bam and bam. You can just get those coordinates by reflecting. Those will all be the same exact coordinate with different negative values. So this blue dot here is also radical 3 over 2 1/2, but the x value would be negative because of what quadrant it lives in. This blue dot down here, what is that, 210? It would also be radical 3 over 2 1/2, but they would both be negative because you're in quadrant 3. And then over here, also radical 3 over 2 1/2. The y value would be negative because of us being in quadrant 4. Does the reflections we do make sense or not? Not at all? Yeah. Okay, so you picture folding the circle in half, reflecting over this reflection line. If you take something here and reflect it to here, it's going to have the same exact x and y coordinates, but the x coordinate will turn negative. Did you do that in geometry? Reflections over the y-axis? No? You're sounding like you have it. Okay. So to take this and reflect it over the x-axis, this reflection line, it lands here. It has the same exact coordinates, but the reflection causes the y-coordinate to become negative. The axis, it's reflecting over the x and y axis. He doesn't get this one. This one is the reflection of this one here. Okay. You see it now? Okay. All right, time for us to do our pink dot. So I'm going to grab my pink marker. I'll talk about what triangle they placed in there, even though you don't need to actually draw it. They placed, this is a 45-degree angle, so they placed a 45, 45, 90-degree triangle here with the hypotenuse that would measure 1. What do you remember about 45, 45, 90 triangles? They are isosceles. They have 2 equal legs. So this leg here and this leg here would match each other. And they both have a measurement of 0.707, or radical 2 over 2. So every single pink dot on your whole entire triangle, maybe you're not using pink like I am, maybe red, would be a radical 2 over 2. The x and y coordinate would match because an isosceles triangle would live inside of the circle. So let's just start reflecting. This is going to be pink. This is going to be pink. And this is going to be pink. Every single one is radical 2 over 2 with negatives placed appropriately depending on quadrant. Oh, I forgot my negatives over here. Over here in quadrant 3, they're both negatives. In quadrant 4, the second one's negative. I think I'm good. Just a reminder, if you get home and you want to study and you're like, I hate my unit circle, it looks like chicken scratch. You can Google filled in unit circle and just print one off. It'll look really beautiful. It'll be all typed and you can use your highlighter to color coordinate it. Okay. Yeah?
So these values for each of the coordinates, how do we find those?
All right, so the question is, how do we find them? If you want to find them, you would use a Pythagorean theorem and some geometry. So I could maybe put a variable here. Since we're already using x's and y's, I would use n's. And you could say n squared plus n squared equals 1 squared. You could solve for n. I'm not asking you to solve all these. I'm just kind of asking you to label them and measure them. But that's where they're deriving these values from. Okay. That would just take a lot more time if we derived every single value, but it is possible. You would use sines and cosines and tangents in the Pythagorean theorem to solve all these measurements. All right, we ready for our greens then? All right, so our green, they would put a triangle in here. This triangle would have a 60-degree measure down at the bottom and a 30 up at the top. So it's really just reverse what we saw back when we were at this 30-degree angle. This would be our x, this would be our y. So what measurement is bigger, x or y? Definitely the y. The y is going to be that 0.866 number. So the y is going to be your radical 3 over 2. And then the x is going to be the 0.5, the 1/2. So really, those are your only 3 choices to choose from: 0.5, 0.866, and 0.707. All right, you ready for some reflecting fun? So 60 is going to be green. Who's going to be green over here? 120 is going to be green. Who's going to be green down here? 240. And who's going to be green over here? 300. Every green will be the same coordinate. 1/2 radical 3 over 2. Just make sure your negatives in the right spots. 1/2 radical 3 over 2. Double negative. 1/2 radical 3 over 2. Y is negative. I'm going to pause my video just because I feel like it's getting long. All right, we're back recording our video. Go ahead and put this somewhere, like in a corner of your circle. You are going to need to know that cosine is an x value, sine is a y value, and tangent is a y over x. So, for example, they're going to have you use your unit circle to answer questions like this. Tell me what cosine of 45 is. So you'll just head to 45, you'll point to it with your little finger, and you'll grab the x value, because cosine means x value. So just for fun, what is the x value at 45 degrees? You just grab the x value. So you just look at the coordinate, and you grab the first part of the x value. All right, we'll try one more sample problem. I'm just making these up out of my head. How about the sine of 225? So everybody go to 225, point to it. Right, we want the y value. We want the sine value. That would be the y value. Negative radical 2 over 2. All right, and let's just try tangent. Let's try tangent of 0. So you go to 0 on your unit circle. You would want the y value and the x value. So we need to divide that. So what's the y value? What's the x value? Are you allowed to do 0 divided by 1? No. Yes, you are. If you don't believe me, type in your calculator.
0.
0. Now, question. Do you think you could use the calculator to check all these answers? Yeah. Absolutely. Let's try it. Cosine 45. Type enter. It's 0.707. Oh, that's probably why I had you write down 0.707 is equal to radical 2 over 2. Okay? Let's try sine of 225 and click enter. Negative 0.707, so negative radical 2 over 2. And let's type in tan of 0 and click enter. 0. So you see how the calculator can be a great tool to check? Check that you're using your unit circle right. Nick? All right, I do have a filled-in unit circle so you get an idea of how pretty they look if you print out a filled-in one from the internet. But I want to do these last 2 questions. Cosine negative 180. Do you see where the negative is placed? The negative is placed with the angle. So you're going to want to actually spin in a negative direction. Do you know where we would land after a negative 180 spin? Right about there. And so what is the x value right there? Negative 1. Yep. Now this is a little different. Negative sine 270. We actually want to spin to a positive 270. Where would that be located? Right about here. We would want to do the sine value. So what is the y value there? And since the negative's out front, you want to apply it last. So that answer would actually turn into a positive 1. So do you see the difference if the negative is placed here versus out front? Because they do that in the homework. Some negatives they place with the angle, some of the negatives they place out front. Alrighty. Let's do the tangent one on this page. The tangent ones are always a little bit trickier because you got to do dividing. Where is 225 located? Let's find it. Right about here. So if I'm going to use tangent, I need to do y divided by x. So it would be a negative radical 2 over 2 over a negative radical 2 over 2. Isn't that the same number on top and bottom? So what's our answer? Why don't we check ourselves? Type in tan 225. Yep. Awesome. That's a great way to check. No, not for that. Now, if you're doing something after it, like adding something to it, then yeah. Let's try a few with radians, so we can practice finding the radians on the circle. It's kind of like a scavenger hunt. Where is pi over 6 located? Let's find it. Bam. So our y value would be? No, I'm sorry. It's cosine. The x value. I asked the question wrong. It's radical 3 over 2. Yeah. Let's try sine of 2 pi over 3. Where's 2 pi over 3? Found it. And then since it's sine, they want the y value. Radical 3 over 2. Positive radical 3 over 2. Let's do tangent. It's always good to practice tangent. Where is 3 pi over 2 located? Found it. Now tangent is y over x. So what's the y value? And what's the x value? Can I do a number divided by 0? It's undefined is how you would write this solution. Undefined. Try typing it. Well, don't type this on the calculator. If you're in degree mode, you're not going to want to type a radian in. But if you would type in like tangent 270, for example, it'll tell you error, and it can't be done. So there's that. Yeah, these aren't too bad. What I did not tell you on the video yet today, I told my last class, is I have this written down here on my board because it's not going to go on the formula board. Memorizing that cosine is x, sine is y, and tangent is y over x. You're going to have to memorize. I'm not giving it to you. But there's a memory trick. C comes before S in the alphabet. X comes before Y on the alphabet. And then just remember for tangent, Y is on top, X is on the bottom. That's it. I want to do the one with the letters real quick, and then we'll hit up tangents again. These letter ones I always find to be really fun. You're just going to answer with a single letter. So sine 90. Look at 90. What letter would be sine? That makes sense? Cosine negative 90. Let's go to negative 90. Where would it be? Probably about here. What letter would be cosine? How in the world would you figure out where 480 is? Good, you remembered from Friday. I'm proud of you. So it's going to be where 120 would live. Probably about here. What letter would be sine? U. You're just answering single letters. Right? There's one in the homework like this. That's why I'm going to do this one. And then let's kind of finish the day off with a tangent thing real quick. Tangents can just be so much harder because of the fractions you need to divide. Do you guys remember how to divide fractions to begin with? How do you divide fractions? No. You multiply by the reciprocal. Let's try tangent of 330, for example. Everybody look for 330 on the unit circle. I'm going to move this up to give myself workspace. 330. Did you find it? So what's my y value? Negative 1/2. What's my x value? We can't actually divide fractions, but we can multiply by the reciprocal to help us simplify. So you keep your first fraction the same, and you multiply by the reciprocal of the second fraction. And that's going to allow you to simplify a lot of these down. Our 2's cancel. We've got negative 1 over radical 3. The scholars would probably rationalize that denominator, but I'm okay with you leaving it. Let's try 120. Where's 120 located? I better find mine. Found it. I don't have much workspace now, but I found it. So my top number is y, radical 3 over 2. My bottom number is x, negative 1/2. I'll move it up out of the way again. We're going to go ahead and use multiplying by the reciprocal for the bottom fraction to reduce. So keep your first fraction the same, multiply by the reciprocal for the second fraction. What'll happen?
They will cancel.
Yeah, that's why I love tangents. It's always something canceling tangents. And then the very last thing, there are 2 places on the unit circle where tangent is undefined. We already found one of them. It's down at 270. Can you think of any other place where tangent would be undefined? Good. How do you figure that out so fast? So tangent would be undefined here because it would be a negative 1 over 0. And you can't divide by 0. Tangent up here would be undefined because it'd be 1 divided by 0, and you can't divide by 0. And those are the only 2 places where tangents would be undefined. Okay? So, people at home, thanks for watching our video. A worksheet, if you are at home and you need it, is here at the end of the notes. But also it's on the back of the unit circle paper, so if you've received that from me, you have it. Okay, any questions? All right, have a happy Monday.